this time on key value storage. Now the good news is this concept isn't particularly complex, and indeed we've actually seen this, or at least an example of this, at least once before. But before we dig into what this concept is, first let's do a quick recap. There is a similar type of storage, and when I say storage, I mean like in a variable, when we store variables and things. So there is a similar type of storage that we've already seen that handles groups of values. It's pretty much the way we've been doing all lists of things so far. Do you remember what they're called? Arrays. So we've already been working with arrays. So let's do a quick recap of what arrays are and how they work, because this will link very nicely into the concept of key value storage. So with arrays, they're a container that holds a fixed number of values. And I've just made a recap diagram very similar to the one that I showed when we first introduced the concept of arrays. So you have a giant container drawn there in orange, and that container would be your array, and it would have a name, for example, my array name. And inside this big container would be lots of individual pots for individual values or variables. So in this array, I have 5 pots to put values in. And in an array, those pots are numbered. Remember, of course, that things are zero-based in Java or Kotlin. So I have 5 pots there, numbered from 0 to 4. And inside those pots go our values, our variables. In this case, I've got 5 strings there. So an array is a container that holds a fixed number of values. And the word fixed there is crucial. Once you've created an array, you can't then later change the size of it. So this array here, my array name, will always have 5 values. And that is fixed. We must specify size when it's created. There's a few ways to initialize arrays in Java and also in Kotlin. But fundamentally, when it's first created, that size, that fixed number of values, that must be set upon creation. So I've got the Kotlin example here. We declare a variable, in this case I call it employees, and the syntax for the array initializer block in Kotlin, that useful bit of code where you can provide the values at array creation, is array of brackets, and then whatever the values are. So in this example here, I'm initializing the array with a size of 3 because there's 3 values there. So if I was to do employees.size, well, that would be 3, and that is fixed. This array will always have 3 values. Even if you change the values later, the size will always be 3. And you access each value by its index, by its number. So once you fill up the array with values, Claire, Steve, Jenny, well, they're assigned an index and number depending on what order you add them in, and that is how you access them. So for example, for Claire, it would be employees, square brackets, and then 0, and that's how we access Claire. And in a 0-based index, can you think how you access Jenny? Well, that would be employees, square brackets 2 for Jenny, 0, 1, 2, Claire, Steve, Jenny. So with an array, we have a fixed number of pots, we put things into those pots, and we access those things by number. So that's a recap of arrays that we've got extensive lockers, even as if you want to. This is just, the key is often is equal to string dot put extra. I'll show you from our on right there. And so, rather than moving to the workshop now, we'll actually see this in action in our activity lifecycle playground. We have a real world example, and this links beautifully into the previous tutorial where we had the device rotation to store an activity. This real world example you can see in action now will show you key value storage and why it's so useful. Back now in Android Studio to see another real world example for where key value storage happens. I've made one change to the layout of activity_main. If I just rotate it, and if I go ahead and type a message to save, hello, this is my message, and done, and then click save message, we get the preview. But I've just made the layout scrollable. If you recall before when we were playing with the device rotation and seeing how this text view could disappear when you rotate, well, when we turned to landscape, we couldn't really see everything because there's not enough height. So all I've done, if I go over to activity_main, I've taken the constraint layout and I've put the whole layout inside a scroll view. This is a quick and easy way to make any of your views scrollable. If there's a chance you might have so much content it fills the entire height of the screen, or you can put your container, your view group, inside a scroll view, make the scroll view be match parent and match parent so it fills the screen, but then make the inner container wrap height for layout height, so it can be exactly as big as it needs to be. You can do this if you'd like, but there's really no need for this activity lifecycle playground. Although if you do want to do this, you can go ahead and put it in a scroll view, and then you'll have to play with the views that are inside the constraint layout, as when you change the height to wrap content, you'll see some things are overlapping. Okay, I put my button underneath the text view, top to bottom of the text view, and I put the other button underneath that. So if you do go ahead and try and copy what I've done, you will have to have a little play around to make the layout work. You don't need to though for the purpose of understanding what's going on. So that is activity_main slightly changed to be a scroll view. But as you can see, when I rotate the phone, your message has been saved, but when we rotate, it all disappears. And we learned a couple of tutorials ago that this is because when you rotate the phone, the whole activity is destroyed and recreated. So back over in main activity. So one way that we can fix this is when an activity is destroyed, there is another callback. It's not one of our lifecycle methods, but it's a callback that happens when an activity is destroyed, and it's called onSaveInstantState. If you were to go ahead underneath the onCreate method, make a few line breaks, and start typing on SAV onSaveInstantState. Now you'll see there's 2 options there, one with outState bundle, and one with outState and one with outPersistentState. Please ignore the one with 2 parameters, and just go for the onSaveInstantState with 1 parameter that says outState, and then autocomplete to override that method. And you'll see here we have this bundle parameter called outState. And indeed, if you look in the onCreate method, the parameter there is another bundle called SavedInstantState. So when an activity is destroyed, this onSaveInstantState method will happen. And this is an opportunity for you to put things into this bundle. onSaveInstantOutState bundle, one of our lifecycle as when you change the height to wrap content, you'll see some things are overlapping. Okay, I put my button underneath the text view, top to the bottom of the text view, and I put the other button underneath that. So if you do go ahead and try and copy what I've done, you will have to have a little play around to make the layout work. You don't need to, though, for the purpose of understanding what's going on. So that is activity_main slightly changed to be a scroll view. But as you can see, when I rotate the phone, your message has been saved, but when we rotate, it all disappears. And we learned a couple of tutorials ago that this is because when you rotate the phone, the whole activity is destroyed and recreated. So back over in main activity. So one way that we can fix this is when an activity is destroyed, there is another callback. It's not one of our lifecycle methods, but it's a callback that happens when an activity is destroyed, and it's called onSaveInstantState. If you were to go ahead underneath the onCreate method, make a few line breaks, and start typing on SAV onSaveInstantState. Now you'll see there's two options there, one with outstate bundle and one with outstate and one without persistent state. Please ignore the one with two parameters and just go for the onSaveInstantState with one parameter that says outstate, and then autocomplete to override that method. And you'll see here we have this bundle parameter called outstate. And indeed, if you look in the onCreate method, the parameter there is another bundle called savedInstantState. So when an activity is destroyed, this onSaveInstantState method will happen. And this is an opportunity for you to put things into this bundle to then restore them. It is your saved instant state, or the state that you want to save when the activity is destroyed and recreated. So we'll leave the super.onSaveInstantState method, and underneath this we'll put something into our outstate bundle. So we'll make a new value, val, and we'll call it our saved text view message. And we'll make this equal to, from our layout, our binding.textView saveMessage.text. And because the text in the text view is a char sequence, not a string, you can just about see that char sequence. So because it's a char sequence, we will do .toString, and that will quickly and easily convert that to a string. So we have captured whatever text is in our text view, the message that had previously been getting destroyed when we rotated our phone, and we put this into our bundle. And the bundle works like an intent extra. It is key value storage. So we'll do outstate dot, and we will do put string, because our value is a string. And if you look at the prompt there, you'll see we have a key and a value. So this follows on perfectly from our previous programming concept on key value storage. This bundle object in Android uses key value storage. So for the key, we'll go ahead and we'll call it our saved message. In camel case, we'll do a comma, and then the value can be our saved text view message, just like that. So this will put the value that we want to retain into the bundle, and the way we retrieve it is in onCreate. When you recreate activity, this saved instant state won't be null, there will be a bundle, and we can go into the bundle and get that value. So at the very end of onCreate, we'll make a couple of line breaks, and we'll just set our text view directly. So binding.textViewSaveMessage.text equals, and we'll go into our bundle, and we'll retrieve this string. So it's our saved instant state, the same bundle that we had in the method below. We'll do a save call, question mark, dot, and get string, and then this will be our saved message. Okay, so let's go ahead now and run this and confirm that our text view retains the text when we rotate the phone. So this is my message that I am saving, save message, and we can see there, your message has been saved, message preview, so that works. We'll now rotate the phone, which we know destroys our activity. Press back, your message has been saved, message preview. So we can see now that we are not losing that value that we need. Remember, our edit texts have this mechanism built in automatically. If I have some content here, dot, 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 and then I close that and rotate the phone, well, you'll see that automatically is retained. It is automatically restored. And the reason for that is Android has helpfully put into edit texts by default this same save instant state behavior. So what we're doing here manually by putting things into a bundle and retrieving them from a bundle, well, Android builds this behavior into a lot of the views automatically, but not into text views. We can go one step further now and actually put some debug points into this. So I'll put a debug point here where we're restoring it, and I'll put a debug point here in our onSave instant state. And you can see that these debug points haven't turned to a tick because we didn't run this in debug mode. So a nice little shortcut is if you were already running an app, but you didn't start it in debug mode, well, the bug with the little arrow says attach debugger to Android process. And this gives you the opportunity to switch to debug mode from an already running process or an already running app. So go ahead and click the debug icon with an arrow, and it will show you all the devices that are running, and then under the device it will show you all of the packages for whatever apps are running. And I can see my Activity Lifecycle playground is there, so I'll go OK, and then you can see now the debugger is connected. I close the debug pane, and I have a little tick on my debug points, so I know that I'm in debug mode. So now when I rotate my phone, well, what do you think will happen first? The onCreate method or the onSaveInstantState method? Have a think. Guess which one you think might go first. Let's rotate the phone. It's the onSaveInstantState. So when an activity is destroyed, it will call this onSaveInstantState and will give you the opportunity to save any values into the bundle. So I'll go ahead now and continue with the debugger. So this one here, resume program. And then almost immediately afterwards, we are in onCreate again. Now, I'm actually going to go into this SaveInstantState bundle. So you can see in the debugger, we have the this for our main activity object. And then we have the one variable we have access to in this method, which is the SavedInstantState. It's pretty much the only variable we have access to in onCreate. So I'll open this up, and you'll see this interesting thing called mmap. Okay, if you think all the way back to the start of this section, I said I'd talk about key value storage, which we've already done. And I also said I would talk to you about a thing called a map. Not a map that you use for directions, but a type of key value storage. So under the hood, this bundle is using this thing called a map, which we're going to cover in the next tutorial. And if I open up the map, there's a few values there, but all the way down to value 4, I can see my message. Okay, so the way this bundle works under the hood, when you put things into it, put string, put boolean, it puts it into some sort of map. And that's the thing that we're going to look at next. Okay, I'm going to go ahead now and close the debugger down, so I'll just continue and close that down. I'm getting a message saying the app isn't responding because we've paused for so long in debug mode, but I can actually press wait, and I can go back into my app. I'm going to go ahead now and just go back to Android Studio. So onSaveInstantState is a very simple way to save any value you might need. That could be some text in your text view. It could be a class property, a variable that you got saved, which of course would also be getting destroyed. So any variable in main activity or your fragment or any value on your screen. We move on now to the final programming concept of this section, and that is on the concept of maps. And this relates directly to the previous program. So first thing to mention is this is not a map as in something you would use to give yourself directions. This is a different kind of map, one that's used for storing variables in a particular way. Things with the phone, a couple of Java we can use it, and the type for the value. So let's see what it looks like in fact, key, and the type for the value. Key, and the key for the value. And you create it, maybe with some initial. Then we set the variable type here. And then we have the square brackets, whatever is in the map, not a hash map, and the key is of type string, and the values are of type int or integer. So this is quite a good real-world example. You might just need to store a variable called scores, which has all of your players' scores in it. You don't change them in the future, you don't need to edit them or delete them, so you can just use map. And the syntax, a bit like our array of syntax when we make an array, is map of, then the brackets, and then you put all of your key value pairs inside at initialization. Now here we can see the strange pair thing, pair, and that's a pair of key to value. Player 1 scores the key, and 5 is the value. And that will create a map of all those keys to values you see inside those pairs, which we can then access later on. For example, we can retrieve player 2 score, we can declare a value called player 2 score, we make that equal to scores, those square brackets again, and then the name of our key, player 2 score. So at first glance, there's a lot of new syntax. We've got hash maps versus maps, we've got the hash map of and map of helper functions, we've got these diamond brackets to help declare our key and our value type, then we've got the square bracket, which is how we access individual items within our map. So let's go through some of these new symbols and this new syntax one by one. So the first new symbol that might be a bit new to us is this use of diamond brackets. And diamond brackets are used to declare the key type and the value type. We have seen diamond brackets before. If you can cast your mind all the way back to recycle views, where we have recycle view adapter of type and we declare the view holder. We use diamond brackets there because when you make a recycle view adapter, you have to tell it what is the type of view holder, and we would go ahead and make our own view holder and put that inside the diamond brackets. We'll see these diamond brackets a few more times as this course progresses, but generally speaking, you're going to see them whenever there's something which needs to know what is the type of the variable, like recycle view adapters, and like now in our map or hash maps, they need to know what type the key is and what type the value is. So there you have map, and then on the left is the key type with comma, and then the value type on the right. And that's how Java or Kotlin knows what type you're intending to use for your key and for your value. So for example, you might have a map where the key is an integer, and then the value is a boolean. A silly example might be you might have a collection of numbers, you might have true if they're even or false if they're odd. So the key could be 2 and the value could be true. The key could be 9 and the value could be false. Okay, so you can have any type for the key and any type for the value. Hash map where the key is a string with 0. So you might have my data. So that's you can go ahead and access that. Student ages. We've already got admin access. It applies our map. Anything which needs a key value pair, you can use the pair object you see on top, or you can use this shorthand key to value just like that. And shortly we'll be moving into the workshop and you'll have a chance to try all of these new utility methods and different ways of passing in the key value pairs, using the pair object, using that to shorthand that we see here. So all this similar syntax, which might seem a bit overwhelming right now, we're going to explore in practice, where it should start to make a lot more sense when you're using it. So let's head to the workshop now and start playing with making new maps and hash maps. Onto the workshop now for maps and hash maps. We covered a lot of things in the previous programming concept tutorial, a lot of new syntax and symbols. So now's your chance to have a little play with these things in practice. I've gone ahead and made a new Scratch file called maps, and I've done one extra thing. I've gathered up all these Scratch files which are sitting in the Scratches folder, which are our programming concepts. And I've created a new programming concepts folder with right-click, new directory. I call it programming concepts. So now it's very clear. Now in this workshop we're going to use at, it is, you can add, amend, delete key value pairs after initialization. Now key value, Kotlin or and we'll say this is of type map this time, just plain old map. And we'll make this string key but an integer and int value, just for change, and we'll say that's equal to map of. Okay, so hash map of, very similar to the array of function we use when we do arrays in Kotlin, is a very useful way to create an empty map. So we can notice about this, just saying exactly this, we can use hash map of and map of as a Kotlin convenience function to make a new hash map, or map effectively. And we'll just talk about the fact that we need to declare the type here. So where's the hash map? That will be an empty hash map because there's nothing inside the brackets in the hash map of function. So because we haven't given any contents, Kotlin can't infer anything, can't work out what the key or the value type is, there's no context for it to work that out. So we need to declare the key value type. And we do that here in specifying the variable hash map of type string, comma string. And if we look at the empty map, well, we've just covered the fact that maps are read-only. Once you made them, once you initialize them, you can't actually add any more data. So it says that this is fairly useless. We made an empty map called empty map of type string int, but we can't actually add any more data to it. So that's just a useless empty map. Okay, so typically if you're using the map of function, you would initialize it with some data, and that'd be a read-only map. And we will have a play with initialization later on in this workshop. Now, it's worth mentioning there is another way you can make a new hash map. You can actually do the traditional object creation thing that you might have done in Java with the new keyword. I'll just show you what this looks like. So we'll do a new variable called another hash map. And we'll make this a type hash map again, hash map. And we'll say, I don't know, string to boolean just for a change. And we can just make the hash map object like this. So hash map, capital H, capital M, and brackets. And that is absolutely fine. And if you cast your mind back to Java, you would make a new object with the word new, so it actually look like that. You don't use the word new for Kotlin, of course, but that's how you actually do it in Java. The hash map of and map of Kotlin functions are Kotlin only, and their conveniences. There's some extra things you can do, especially around initialization, which we'll talk about in a moment. So I'm going to mention that you can do the traditional way if you want to. So we'll just say that we can also use the traditional way of creating a new hash map object. This will work in Java with the new word. Okay, so that's how you do that in Java. Now I'm going to show you how to do it using a map and show you what problem we run into. So now we'll try and object just like that. And we have a class you can create new objects of a hash map. But if I command click on the map, well, that's just an interface. And indeed, if you look at the top description of this interface, a collection of pairs of objects. Okay, this is a recap. But the key thing here is methods in this interface only support read-only access. So in the map, you can only read them. Okay, so we can't use the old-fashioned map object as a way to make a new map. So because of all this inconsistency of what you can and can't do between hash maps and maps, I highly recommend you use the hash map of and map of functions. Let's just make a note saying why we can't do this. So I'll do an arrow and I'll say this won't work. Map is actually just an interface with read-only methods. So because of all this, a key bit of advice from me right now, if you're going to be working in Kotlin, especially for consistency with arrays, and also convenience, which we'll see when we get to initialize in a moment, I highly recommend using hash map of, as well as array of. Okay, there will be other collections we use later on in this course, not just arrays and maps or hash maps, and they all have this convenience method of something of, array of, map of, hash map of. Consistency in your code base is a really good thing. So creating maps, or at least empty maps and hash maps, pretty straightforward. So we'll do a new section now. So 3 stars, this is to do with updating and accessing values in hash maps. So we'll go ahead now and make a quick hash map. I'll make a real world example now. So we have a hash map variable which we'll call pets. And we'll make it a type string key and string value, nice and simple, so I can show you the concept. And I'll just go ahead and make it equal to an empty hash map. So hash map of, nice and easy. So the default way of putting things into a hash map, and indeed the Java way, would be to do the name of the variable, pets, and then dot, and then a method called put. And you can see that's expecting a key and a value. So I can go ahead and say a pet that I don't have, so we'll go for Fido. I don't have a pet called Fido, and that will be of type dog. So this is a map that gives you the name of the pet as a key and what the animal is as a value. So Fido dog, and that would be absolutely fine to put something into our array. So we'll just say this above, we'll say you can use put key value to store, or even update the value already exists, a key value pair in a hash map. However, you'll notice there's a little suggestion under the word put. When I hover over it, it says this should be converted to an assignment. And that's a fancy way of saying to use the square bracket syntax that we saw in the programming concept previously. So we'll just make a quick note to say you will get a suggestion to simply use square brackets. I'll just say this makes it consistent with arrays and their index. Yeah, if you remember, we were doing array, like some array and then the index, like that. Yeah, so we've been suggested to do this to be consistent. So let's do exactly that and put another value into our array, but this time using the square brackets. So we'll do pets again. So this time I will do a pet that I have. I have a cat called Max. So square brackets and just the value of the key, and then the name of the key. So that's on its own will just retrieve the value if any. So making those to that key. And this is similar to how we assign values to new variables. So square bracket syntax doesn't exist. Fido, this outputs dog, which is the same as what we put in under Fido. So get works absolutely fine. So we'll mention this. We can use get and then the key to retrieve the value for a specified key. But again, you will get a suggestion to use square brackets, just like for put. You'd have to use get and try, but we don't have to use that, and we can use the consistent square bracket style. So underneath, we will now go ahead and get the value under max. And if we look there, line 30 in the console, I can see the value for max is cat. Good. So we'll just say that. Using square brackets is the recommended way. And we'll say max again. We'll be more specific. It's actually an Arabian Mau cat. He's an absolutely fantastic cat. I think the world's oldest breed of cat, the Arabian Mau cat. Somebody told me. So if now I go to pets max, what you can see on the console to the right, it's now an Arabian Mau cat. Good. We'll just make a note next here saying that we can update any existing values in the same way as we create new ones. Just the map, a name for the key, and then equals. That will either update or create a new value if it doesn't exist. And then to remove a key value pair, we do now call a method. So pets.remove. You can see the name of the key. So I'll remove Fido as I don't actually have a dog, especially one called Fido. So pets.remove. I'll get rid of this. So to remove a key value, pets. And indeed, if now hash maps. So we can make a hash map that includes a student object. So we'll call this our student data hash map. We'll make it a hash map, and we'll make the key of type string for the student identifier, and then the value can be actually the student. So it can be an object like that. And we'll make this equal to hash map of to make an empty hash map. So we'll go ahead now and make a couple of student. We'll go ahead and I'll make the key equal to their first name. Actually, no, I'll make it some sort of fictitious student ID. So I don't know, AL141, and that can be equal to the student object of Alex. And then student data will do RI422 for Richard. And we can actually create any student at the point of assignment. So I do another student. So student data will say SI744. And that can be equal to a brand new student object right here. And I'll go for an Irish name. So Siobhan. There we go. Siobhan and 744. And see what we get in the output. So under key SI744 for Siobhan's student data, we have the student object there. Student name Siobhan23 and Irish. So we'll just make a comment to say exactly what we've done there. So we can put any type for the key or the value. This can include custom classes that we've made. Okay. We'll talk a bit now about initialization. So putting data in the point where you create your hash map. So we'll say map initialization. The data that you show on the screen. Remember in the previous programming concept tutorial, there's a couple of ways to do this. The first way is using a pair object, so the capital P, pair, and that's an object. If you see there as pair, and then direct brackets A, comma, B, just letters representing the first and second infer charges on the so Command D, Control D. This one I've ran out of. So we can add values at the point of creation with these useful Kotlin convenience functions, hash map of, map of. Okay, I'm going to show the syntax for these pair objects, pair of, and then brackets key and value. And we can now access these values, so how do bank balances and do greedy bank, or a hash map. If you look above, we can or do something like a report card. Okay, this can be a map of string to string, nice and simple for this one. And we'll just make this equal to map of. We're going to say it's a one-time thing generating a report card. We don't need to amend it, we don't need to update it or remove things. So map is absolutely fine. Well, rather than using the pair object, you can simply do the name of the key, so we'll say English, and the word to, just like that, and then the value. And you can see the word to there turns this unique yellow colour to show you it's a special word in Kotlin. So English to A, and that'll be key English to value A. Simple as that. It's actually a shorthand for getting these pair objects. You can actually command click on this to or control click, and you'll see some weird infix function thing, but fundamentally it's returning this pair object. Okay, so yeah, English to A will do maths, and that can be to the value of B minus. Science can be to C plus. And then music, my favourite. I was a music teacher in Activity Life, so this one can be my best grade, A+ for music. Me, musician, the former music teacher. So you've also got the option of using this syntax, so we'll make a note. You can also add key value pairs using the following syntax, key to value. And this is simply a shorthand for pair, key, value. You can use either, just whichever one you use, just be consistent with your code base. I prefer to use the second one. It makes sense to me. But also the pairs, the key value pairs there, they also do make sense. So choose one, use it, just be consistent. Try not to use both in a code base. That would be annoying if other developers had to work on that. So that covers pretty much everything to do with map initialization. And the final thing to mention, the final section, is on the idea of type inference, which as you'll know is a thing of Kotlin, a feature of Kotlin. The room name, and then slab, we'll say absolutely not, that's top secret. We'll go for staff room, and well, everyone should be allowed to access the staff room, so that's definitely true. And then the executive suite. That can be false, just for the rich boss. So we've made a new map called secret access, or hash map rather, and we've initialized it with some values. And it's clear to see from these values there's a string for a boolean. Well, in this case, we can actually remove the variable type of hash map and those time brackets, because Kotlin is able to infer both the key, as they're all strings, and the values, as they're all booleans. So that's using type inference. So we'll simply say, if you initialize your hash map or map, okay, the values. So we'll comment this out, and we'll say, once the key and value type are set, you cannot put any again this. For me, maps and hash maps were never really properly explained to me. They're actually quite simple and very powerful, and understanding how they work well the first time will be beneficial to you. So we'll make a code block /start, and we'll make a few bullet points. Some final important things to mention. Number one, the keys must be unique. You cannot have the same key twice. In fact, if you try to do that to set any value to the same key, it will just open a null value on certain keys. But you can type brackets, you might say, a map dimension is that hash map is called this, with a deep type block unique. So your keys have a very common thing in computing. And while under the hood it might be some complex stuff, it's simple. It just takes some data and smushes it and scrambles it into some short, or shorter at least, sequence of characters, which will be unique. Okay, that is quite a lengthy workshop on hash maps, but it's a very useful object. We'll see examples of key stores that aren't hash maps like bundles, but under the hood they are actually using hash maps or maps. Okay, so we've covered this now. We likely will see it once or twice in the future, and we're starting to grow our understanding of different types of collection, not just arrays now, but arrays, maps, and hash maps. And we will continue to add to our library of collections that we can use in Java and Kotlin. So, well done. One final tutorial now in the activity lifecycle section, and we can jump straight back into our record keeper and get that finished.